All right, we're on double replacement reactions. So double replacement reactions are when you have one compound reacting with another compound, and you're going to produce two different compounds. So it looks something like this. I'm going to underline the A and the B in the first two compounds. Those are the cations in each of the compounds on the reactant side. What happens is those cations are going to switch places, and then we're going to get two different compounds. When you're writing out a double replacement reaction, we often use the solubility rules to predict the states of matter for the products. So after you form your products, you have to reference the solubility rules, and if you've got a compound that is soluble in water, then you would be putting a AQ after it. Okay, so I'm just going to write soluble to reference that compound, for example, is soluble in water. If you form a compound that isn't soluble in water, then you're going to put a little S after it. That means you're forming a solid. This is also known as a precipitate, and this is a special type of double replacement reaction known as a precipitation reaction. So if, this is really important, if you form a solid product, which would be on the right-hand side of the arrow, then it is known as a precipitation reaction. And if you don't, and both of your products are soluble in water, then we would say that no reaction occurred. So if you have something like this, where both of your products happen to be AQs, okay, then this would be considered no reaction, because there's no form of evidence that a chemical reaction occurred. Okay, you're just forming solutions, the ions are just moving around, and there's no solid or precipitate formed, which is one of the forms of evidence that we talked about on the first day of class, on the first day of this chapter, in reference to the forms of evidence that a chemical reaction occurs. Okay, but if you form a precipitate, which means you will have a solid product, then this would be known as a precipitation reaction. Okay? Okay, so what I'm going to do is we're going to take a look at page 6 of the chapter handout, and I gave you 3 examples of double replacement reactions, and I'm going to do letter A for you. So let's take a look at A. It says we have a solution of sodium carbonate, so I'm going to write this out in words first. I highly suggest writing it out in words. It'll make it easier. Sodium carbonate and copper 2 chloride. Okay, so these are your reactants. I'm going to underline the cations in each compound because that's what's going to switch. So the sodium and the copper 2 are what are going to switch. When you have a metal with a Roman numeral, make sure you underline the Roman numeral. You want to include it because that will switch with the copper and it will go to the other side. So these switch places, okay, and you're going to form copper 2 carbonate and sodium chloride. The order that you write the products doesn't matter. You could list sodium chloride first or second. Both are acceptable. So I'm going to write this out as, and I'm kind of limited on room, so I'm going to squeeze it together. Copper 2 carbonate plus sodium chloride. Okay, so now that I have it in words, those are my products that I wrote down below, okay, because I ran out of room. I'm going to convert my chemical names to chemical formulas. Okay, and you want to reference the periodic table while you're doing this. Sodium is Na+1. Carbonate is CO3 minus 2. We're going to cross the charges. You're going to end up with Na2CO3. They told me that this was a solution, so you have to write an AQ after it, and it looks like this. Copper 2 chloride is Cu plus 2 and Cl minus 1. You cross the charges, you're going to end up with CuCl2. They said that this is also a solution, so we're going to put an AQ after it. Then I have copper 2 carbonate. That's Cu plus 2, CO3 minus 2. The numbers in the charges are going to cancel, and you're going to get CuCO3, and then sodium chloride is Na plus 1, Cl minus 1. The numbers in the charges are the same, so they cancel, and you end up with NaCl. Okay. Now what you have to do is you have to look at the solubility rules and predict whether the products are soluble or insoluble, and then you're going to write in your states of matter. So I want to look at the CO3 first. So I'm going to look at my solubility rules. Carbonates are mostly insoluble. Copper is not an exception. So that means that this is a solid, so I just formed a precipitate. So this is a precipitation reaction. That's a form of evidence that a chemical reaction occurred. Then you're going to look at the chloride here in this compound. Chlorides are usually soluble. Sodium is no exception. That means that they will have an AQ after it. Okay. Now we have to look at it and see if it's balanced. It is not. Sodium and chlorine have a 2 after them, so that means you have to put a 2 in front of NaCl, and now you're balanced. And this is your balanced chemical equation, and you're done. Okay. You can either leave the coefficients blank in front of the other compounds, or you can put a 1 there. Okay, now for the next one, I'm looking at lead 2 acetate and sodium sulfate. I'm going to underline the lead 2 and the sodium. Okay, because those are the cations in the compounds, and those are what we're going to switch. Keep the Roman numeral with the lead, because it has to move with the lead when it switches to be with the other anion. Okay, all right, so we're going to produce sodium acetate and lead 2 sulfate. All right, now what you want to do is we want to convert the chemical names to chemical formulas. So lead 2 is Pb plus 2. Acetate is C2H3O2 negative 1. We're going to cross the charges. And it looks like this. They told us that it is a solution, so you have to put an AQ after it. And then we've got sodium sulfate, Na plus 1, SO4 minus 2, cross the charges. You're going to get Na2SO4, which is also a solution, so you have to put an AQ after it. Then we have sodium acetate. That's Na plus 1, and then C2H3O2 negative 1. The numbers in the charges cancel. So you get this. And then we have lead 2 sulfate, which is Pb plus 2, SO4 minus 2. The numbers in the charges cancel. So you're going to end up with PbSO4. Okay, now you have to check the solubility rules to see what the states of matter will be on the product. So first we're going to look at the acetate ion in this compound. If you look at the acetate ion, acetates are mostly soluble. There are no exceptions. That means that this will have an AQ after it. For the next one, SO4s are in general soluble. Pb happens to be one of the exceptions. That means that this is going to have an S after it. It is a solid. You formed a precipitate. That is a form of evidence that a chemical reaction occurred. So this is a precipitation reaction. We're not balanced. I have 2 acetates here, so put a 2 in front of here, and then you're done. Okay? Okay, I'm going to do one more. If you're looking at C, you have nickel 2 chloride, and potassium hydroxide. I'm going to underline the potassium and the nickel 2 because those are the cations or the metals in the compounds, and those are what are going to switch places. When they switch places, you're going to end up with potassium chloride and nickel 2 hydroxide. Now we can convert the chemical names to chemical formulas. Nickel 2 is NiCl2. It's a solution, so you put a Q after it. Potassium hydroxide is KOH. They also told us that that was a solution, so put an AQ after it. Potassium chloride is KCl. Nickel 2 hydroxide is NiOH2, just like this. Okay, I'm not crossing the charges here, I'm just doing it from memory, okay? All right, now if I look at the solubility rules, chlorides are mostly soluble, potassium is no exception. That means that this is going to have an AQ after it. Hydroxides in general are insoluble. Nickel is no exception. That means that this is a solid. That's a form of evidence that a chemical reaction occurred. This is a precipitation reaction. We are not balanced. Put a 2 in front of KOH and a 2 in front of KCl. And now you are done, okay? Okay, so if you are doing this and these products end up being AQs, then that means there is no form of evidence that a chemical reaction occurred, and you would write no reaction. Okay? Okay, let me give you a couple other hints. So this is the double replacement reactions worksheet. I gave you the solubility rules at the top as a reference, and I gave you the chemical names of the substances. Remember, when you have an acid, like number 2 is hydrochloric acid, you want to rewrite that as hydrogen chloride so you can see what is going to have to switch, because the hydrogen will end up switching with the sodium. Okay, so anytime you have an acid, rewrite it simply as hydrogen attached to whatever ion it is. It'll make a lot more sense. Down here at the bottom, number 6, I gave you chemical formulas instead of chemical names. Write this out in words first. It's sodium chloride and silver nitrate. Then switch the words, write the chemical names on the product side, and then convert the chemical names to the formulas. Do the same thing back here. Okay, you'll notice on number 8 I gave you HCl, which is an acid. Write that as hydrogen chloride, not hydrochloric acid, so you can see what needs to be switched. On number 9, when I ask you to identify which reactions are considered precipitation reactions, that means you're forming a solid on the product side. Okay, so that means you had to use the solubility rules accurately to predict which ones were insoluble in water, and that's it.